we have the first dual talk of the event today. So Andreea and Achim will be discussing browser-based smart contract UIs. So Andreea, please take it away.
Hi, thank you. My name is Andreea Eftene, and I'm a JavaScript developer at Parity. I'm part of the smart contracts team, and together with my colleagues, I build web applications for smart contract developers. The talk today will be about the current state of our new UI projects, which Achim and I will live demo here for you. I must add that this is just a sneak preview. The two projects we will demo today are not available yet to the public. We are planning to launch the two MVPs by the end of the year. But first, let's start with a bit of history. I'm going to do a quick recap of the core projects as an introduction for those who are new to smart contracts in Substrate and need to know what is available to them at the moment. Without going too much into detail, Inc allows you to write smart contracts in Rust, and Cargo Contract compiles them to WebAssembly, generating the metadata that is so useful for UIs. There have already been workshops about writing smart contracts in Inc, and I invite you to watch them if you haven't done so already. Moving on, the Substrate Contracts node, formerly known as Canvas, is made for developers for testing purposes. It's just a minimal Substrate node that includes the contracts palette, and you can run it locally to test your contracts. The contracts palette is what gives the Substrate runtime the ability to work with smart contracts. Some of you may have used the Substrate Contracts node via Canvas UI. Canvas UI was a web application where you could deploy your contracts on the Canvas testnet or local node. The metadata of the deployed contracts would then be saved in local storage, allowing the UI to generate the right inputs for your contract when you would later revisit the page. I'm using past tense on purpose because we have rewritten Canvas UI entirely and have some cool new features in store as well. This brings us to the present, where two new projects were born in the UI team. One is Substrate Contract Explorer, which will replace Canvas UI very soon, and Ink Playground, a special browser IDE for Rust-based smart contracts. Now, let's talk a bit about the Explorer and how it differs from Canvas UI. It builds upon the deployment and interaction features that were present in Canvas UI with the main goal of improving developer experience. We also want to create a developer community around Rust-based smart contracts where people can learn from each other, where anyone can easily inspect, modify, and redeploy contract code written by other members of the community. The new contracts UI will show useful statistics to the users, such as how many instances a contract has and so on. Users will be able to log in using a Substrate account and will be able to star their favorite contracts, similarly to how you would star a GitHub repo. By replacing a local storage with IPFS, the UI for your contracts will be available anywhere, and deployment of complex contracts will be much easier. We had a lot of feedback from Canvas UI users that error messages could be displayed in a more helpful way. So this is something we are looking to incorporate as well. In a nutshell, we want to create a complete web experience for smart contract developers. As I said before, that includes the ability to modify contract code in the browser. So I will now let my colleague Achim share his screen and tell you more about the Ink Playground.
Hi. My name is Achim Schneider, and I'm a smart contract tooling developer from Parity Technologies. So I have a background in React TypeScript and also in Rust and WebAssembly. And what I will talk about today, well, as we have learned earlier in the conference, like there will be an increasing demand also in tools for education and e-learning regarding Substrate and Parity and Polkadot. And so Ink Playground there comes in handy. Like just imagine that you go through some tutorial about Ink smart contracts. You're new to the topic and you just want to try out coding your own smart contract. And then currently this means that you have to install quite a heavy machinery of tools and like things like the Rust C compiler, like cargo contract, the latest nightly toolchain, probably some Visual Studio Code plugins, just to start experimenting a bit with the language. And even if you're an experienced developer, maybe you just want to try out some code snippet without creating a new project on your hard disk. And yeah, like what Ink Playground provides you is actually a browser-based IDE, meaning that you just have to enter a web address in your browser, and it provides you with a fully integrated development environment. So this means you can start editing, writing, editing, compiling, and sharing your smart contract code there. So a really nice feature that it includes is that it provides you actually with Rust Analyzer. So this means that Rust Analyzer is usually a plugin which you have installed working with Rust or Ink code on your local desktop IDE. And we managed to actually compile this tool to WebAssembly and execute it in the browser. So it provides you with features like syntax highlighting, auto-completion, GoTo definitions, function signatures of functions you are trying to call or that you are calling from your smart contract code. So it's a really nice and cool feature, really useful for smart contract development in Ink. And it also allows you to load all the Ink smart contract source code, so that you really see like what functions you are calling, what parameters are required, what's the return value. So yeah, then next, when you're editing smart contracts in the browser and you would just like to check if those smart contracts compile, or you would actually want to compile and download them to deploy them with Contracts Explorer, yeah, you can do this. So it provides you with a one-click compilation functionality of smart contracts to WebAssembly. And then last but not least, it also allows you to share the code you're editing. So there's a button which allows you to create a GitHub gist, and then it provides you with a link to this GitHub gist, so that just in the case you are stuck with a bug while editing your smart contract and you would like to discuss with other people, then you can create a GitHub gist with one click, and you can share the link to this gist in a forum or with a colleague, or you actually it also provides you with a second link to the Ink Playground itself, which encodes the ID of this GitHub gist. So if you share this link with someone, then this other person will be provided with the Ink Playground IDE, and it actually, opening this link, it already automatically fetches the GitHub gist content for you and provides you with the content of the smart contract code you were editing. Okay, this is actually a small screenshot of like how the Ink Playground currently looks like. And you see it's currently separate from Contract Explorer, but you can imagine that this becomes like a really, really useful tool in the future when you that at one point in the near future, you will probably be able to write your smart contracts in the browser. Then you can compile them, you can deploy them on some chain or your local node, and then something doesn't behave the way you expect it to be. And then you can just jump back to the source code, modify a few things, recompile it, redeploy it, and it's just one workflow of smart contract development. So that's what we aim to accomplish. Okay, so let's just jump into some live demo and see how we can actually currently edit smart contract code with Ink Playground. Okay, so I open the website, the web address, and you see it loads the Playground, and it provides you with a code editor. It takes a few more seconds to provide the Rust Analyzer, but it's something that you're also pretty used to when, in case you ever use Rust Analyzer in Visual Studio Code, it just takes a few seconds to load all the project dependencies into its database. Oh yeah, and that's already available. And then you see that I can just navigate through the source code and that I can hover over some things, and it provides me with like with the function definitions, and it allows me to actually, I can jump to function definitions. It provides me with the required parameters. It complains about syntax errors, and actually that's like a pretty cool and useful feature. So and then let's assume that there is some typo somewhere in the code. Oh, actually that's a typo which gets already like marked. So and I try to compile, and you will see that it won't compile. So there's some much more complicated error, which currently, like the Rust analyzer itself at this stage doesn't reveal, but then trying to compile it, it throws an error and it provides you with a backtrace, and you will be able to fix the error. And then, it will actually compile, and you will be able to download the contract bundle. And then the last thing I was talking about was that it also provides you with some sharing functionality. So let's see how this works. I can create a GitHub GIST, and then I can either open this GIST, and you see that it actually created a new GitHub GIST containing the source code. And yeah, actually the source code that you see here, what this is, it's just the standard ERC20 token. It's the source code defining ERC20 token, so quite standard smart contract example. And here's the second link I was talking about before, and this is actually the link which allows to open the playground and load the content that I was currently editing. And what I will do now is I will copy this link, and I will share it with my colleague Andreea. Actually, I can also click this button. And Andreea will open the link and will just one-click compile this ERC20 contract and then download it and deploy it to Contract Explorer. So Andreea, here comes the link.
There we are. So I have opened the Explorer, and now I will compile the contract. This usually takes a few seconds, even on my host, but it seems like it's much faster here. I have downloaded the contract, and now I'm moving to the Contract Explorer, where I need to upload the new contract code because we just compiled it. Here I'm presented with the instantiation form in 3 steps. I can input my contract here, give it a name. Here on the next step, we can choose the deployment constructor, but in this case, we have only one. I can pass a value here. The instantiation options are pre-filled with the default values, and I'm not going to change that at the moment. On the last step, we can review our inputs and instantiate. So the instantiation is complete now, and I have been redirected to the contract page, where I can inspect the metadata, where I see useful information about the methods that are available on this contract. And I also can, for example, check the balance of the contract owner, or even transfer some funds to Bob. This usually takes a few seconds. A few more. All right, looks like the transfer succeeded. I can now check the balance of Alice again and see that the amount was subtracted from Alice's balance. One last thing I want to show you is how quick it is to reinstantiate a contract. You see the UI has been populated with the on-chain code hash, and I just can click, instantiate. All right, so that completes our sneak preview live demo. I will now move back to the slides where we can talk a bit about future plans. So as I mentioned earlier, the two new projects will be launched very soon in an MVP phase. What does that mean exactly? For the Contracts Explorer, it means a tool for local development that has all the previous features of Canvas UI. In the MVP phase, it will only work with Substrate Contracts node or any other local node that has the contracts palette. For the Ink Playground, it means that it will be a standalone app at first, moving towards a full integration with the Explorer. The Contracts Explorer will get the ability to deploy on any chain soon after the MVP is launched. And sometime in the second half of next year, we expect to complete all the milestones, including the IPFS community and the integration with the playground. Okay, that was all for today. Thank you so much for watching.
Thank you very much, Andreea and Achim. That was very very interesting talk. We had a couple of questions come in from the QA. I think first, just would you have any recommendations for people who are interested in learning about Ink, about like starting on it, that they could then use your tools?
Yeah, sure. So we already have a few tutorials available, and also the previous editions of Sub0 had some workshops that I think are very interesting for newcomers. And as I said, in 1 month we will launch these two new tools that and also provide some new tutorials for people to learn.
And I heard you mention at the end that like there's sort of a second step coming where you'll be able to deploy to different chains and different parachains. Are there any difficulties in deploying from one chain, providing support from one chain to another, or is this just pretty straightforward?
It's one of those things that looks straightforward but isn't. So yeah, we expect it to be done very soon after the MVP. So it's not where the greatest complexity lies.
Okay. We actually had several questions about VS Code.
Okay.
Yeah. So are there any plans to make an extension directly from VS Code? Like take this? Is that something that's possible to do?
I mean, it's currently not on our focus, and I would say that like Rust Analyzer is a pretty good tool which is available for Visual Studio Code and which allows you to provide you with quite some nice tools, which are of course developed generally for Rust. But our focus was currently more bringing this into a browser-based IDE because in the end, like Ink contract code is actually Rust code together with some extra macros. So I'm not aware of any plans of any current ongoing activity for a specified Visual Studio Code plugin, but yeah.
So how do you mitigate against like malicious like code injection attacks? Like, is there something that people could try to put in some sort of smart contract code that actually would interfere with the IDE running? Like, do you sandbox it somehow?
Yeah, actually, we sandbox the compiler, but our main first target for those tools are actually to provide a tooling for learning and tutorials, and then we like regarding the playground, the compilation is handled in a sandbox, yeah, and it's secured, but yeah.
Okay. We had someone ask, what is your opinion on Ask, which is the assembly script sort of variant of Ink, and if you had any plans to work with that as well, or feature that, integrate that into the code.
So yeah, the Sub0 Contracts Explorer is meant to work with any kind of smart contract that compiles to WebAssembly. So it's not necessarily linked to Ink. This is definitely something we want to do in the future.
So I think those are all the questions that we have. We're a little bit early, but thank you very much, Andreea and Achim. We really appreciated you showing this to us and going through everything and answering all of our questions.